Hello and welcome to our webinar. I'm Matt Griffin, Director of Community Development for Ultimaker. For this session, Optimizing Your Ultimaker Cura Workflow, we are going to offer something special. Today, I will be joined by two of our in-house Ultimaker Cura experts, Ultimaker Cura developer Kostas Karma and Ultimaker application engineer Terri-Ann de la Cruz. And together, the three of us are going to lead you through a handful of real-world example projects to offer an Ultimaker masterclass focused on Ultimaker Cura workflows used by our top customers out in the field and informed by insights from our very own Cura developer team. During this session, we hope to provide you with direct insights into how you too can draw on the power of Ultimaker Cura for your projects. We'll explore three common parts scenarios that we nicknamed as the strong, the beautiful, and the, well, assembly. We thought that worked. While these parts represent just a few of the final output goals you might have, we hope that exploring these may provide some keys you need for your own projects. A few keys topics that we will include: some tips for exporting your part drawings from CAD and bringing them into the Cura environment, best practices for iterative print preparation and how you can learn lessons from every print, making more use of machine, material, and print profile settings to build on your successes, producing parts over time as an individual and as a team, the mysterious, powerful per object settings, those tools and the real-world scenarios when they are most useful. So we created this session to serve our intermediate and advanced users. But if you are more of a novice Cura user, don't despair. We hope to keep our journey through these parts clear enough for you to follow and become familiar with some new commands and approaches that you may want to add to your own Cura practice. We really want to hear your questions. Our team will be in chat answering questions all session long. The agenda for the sessions is this. First, I'll guide you through a high-level Ultimaker Cura overview, very briefly, to set the stage. Then, for the first stage of the masterclass, we will be joined by our two experts and start with the 3D control software aspects of Ultimaker Cura. Everything from bringing in digital objects through to staging them for the slicing process. Next, the second stage of the masterclass. We will focus on the slicing process itself, the printing strategies, and finally, the last stage of our masterclass focuses on insights for Ultimaker operators, adding in Digital Factory, the Ultimaker Marketplace, and other resources specific to our hardware, software, materials, and training products. So as a quick overview of Cura, Cura is an open source 3D printing utility used to import 3D designs and prepare job instructions for producing physical parts on 3D printer hardware. Cura was initially created in 2012 by David Bram, who then joined the Ultimaker team and brought the software development, leadership, and maintenance in-house. Ultimaker continues to maintain and develop Cura today, together with the collaboration of a passionate community of online developers. It is important to note that while Cura is the preferred 3D printing software for Ultimaker 3D printers, this package is also used by many other 3D printer hardware vendors and users, including those developing experimental or custom-built equipment. Over the years, Ultimaker Cura has gone through a number of major revisions on GitHub. It now serves over 1 million users worldwide and now reports over 2.5 million print jobs per week. So what is Ultimaker Cura? I ask this again because the answer isn't as obvious as you might think. 3D printing is the most common use put to the software. The process of preparing those job instructions, those path instructions for 3D printer hardware, delivered using long sequences of G-code commands that tell the machine to move the extruder to position X at this speed and set the temperature to Y at this moment, as an example for G-code. But Cura as a software package does other things as well. It is a utility for importing digital meshes delivered in a number of file formats. It allows you to transform those meshes, move, rotate, scale, and mirror them to assign the precise build position intended. Cura manages an array of profiles, machine, materials, and slicing profiles that make it easier for a user to prepare a job for an exact machine, material, and engineering outcome without having to assign every single value from scratch each and every time. And for Ultimaker hardware and software, there have been new layers added to make it easy to draw on a marketplace of software and material plugins, manage clusters of printers both locally and over the cloud, be able to see what materials are loaded, and things like that. So Ultimaker Cura is not just one thing, it is even just three things. But dividing this between 3D control software, 3D slicing software, and 3D management software is a handy way to see the whole sequence. And this is how we are going to go through the sequences ourselves today in the masterclass. Ultimaker Cura allows for not just one workflow, but many. So Ultimaker works closely with our customers to help them make this workflow as seamless and frictionless as possible while helping the whole field hopefully have a better experience of slicing. So we are thrilled to introduce you to our new format today, a masterclass, where we get to dive in deep to the Ultimaker Cura values. And I now have the privilege to introduce our experts. So Terri-Ann is an Ultimaker application engineer working in the field with our top customers. She is a wealth of knowledge, understands how our customers use our software, and guides new customers to benefit from these successful strategies. Before joining the AE team, she worked on the Cura team as a software tester. So she's been with Ultimaker for 3 years and started her Cura journey since 2.7. Kostas is a software developer from the Ultimaker Cura team. He is passionate about Ultimaker Cura and the roles it plays in making a lot of workflows possible for end users, including those with third-party machines. He has been working on a slew of features from network connectivity to tools helping our material partners make better profiles, and more. So welcome our new experts on our show. Okay, so now we've met our human experts, but we have more guests. So Terri-Ann, do you want to introduce our hero parts?
Yes, thanks, Matt. I'm really excited to introduce to you our heroes for today. So Matt has already mentioned them to you, the strong, the beautiful, and the assembly. To be honest, I actually didn't get the joke at first, and then Matt had to explain it to me. So our strong hero today is going to be the Ultimaker press tool model. We use it for pressing the metal bearing at the back of an Ultimaker machine at the feeder. For our beautiful, we have a skate prototype. You will understand why we used it specifically for demonstrating beautiful parts. And for the assembly, we have a press tool for the slider blocks for Ultimaker printers. So for the strong and for the assembly, we want to let you know that we use this for production. And you will understand why we called them that way and why we are using them as our heroes.
So almost any software out there can export the common formats used by 3D control software, STLs, 3MFs, etc. So in the case of these files, pieces were actually created in SolidWorks. And then the designers could then export the mesh files as 3MFs or STLs and bring them in. But Kostas, you want to talk about some of the other file formats that Cura can understand for bringing in?
Absolutely, Matt. Actually, Cura can understand most of the most popular 3D formats out there, such as stereolithography files, which are STLs, .obj files, X3D files, and the 3MF files. And I would like to stand a little bit more on the 3MF format because this is the preferred format that we use in Cura mostly. This format was developed or started being developed about 5 years ago by the 3MF consortium, which Ultimaker is also part of, and along with other big players in this 3D format arena, like Stratasys, Autodesk, Microsoft, and many others. And this is the preferred project file that we use in Cura for a number of reasons that we will actually analyze a little bit later on during the video.
So yes, you always need to add a printer first in Cura before you can start anything. Because of course, if there's no printer, where are you going to put your models on, right? In my Cura that I have open right now, I have added an S3. This S3 actually belongs to Matt, and he's in Brooklyn, and I'm here in the You can also add other printers, not only Ultimaker printers. And I think, Kostas, would you like to tell more about the rest of the other printers?
Absolutely. As you can see, Terry, there is a whole bunch of different printers that are available inside Cura. And of course, not all of them are actually developed by Ultimaker. So the idea is that we support third-party machine definitions that have been contributed to us by the community.
That's correct. And in this case, I've added the custom FFF printer, but I'm going back to Matt's S3. So now I'm back here. There are some other things that you should know when you're using Cura for the first time. There are settings in the preferences that we have enabled or disabled by default. And this is because it's a best practice, and it makes Cura more intuitive and easier to use for you. One of them is automatically dropping models to the build plate. When you have loaded the model, it will automatically drop to the build plate. And the other one is ensure models are kept apart. If this setting is enabled, it will make Cura move your models apart so that they won't be touching each other. So sometimes you want that, and sometimes you also won't really need it. You will see some examples later because we will go through the rest of our heroes. There is also another setting that I think you should be aware of, and that is
the auto-slicing option.
Yeah.
That is also one of the settings that I use very often, and it's quite widely used. And it's the one that allows you to automatically slice everything that you have on your build plate whenever you make even the tiniest change in your models or in your print settings.
Yeah. So if you notice, if you look at my screen now, if I change the setting, it immediately slices.
So now let's look at the hero parts, and
Yes.
Terri-Ann's already been working with them, and the decisions that you made for how to place them.
Yes. So we're going to start with our strong hero. So I mentioned earlier that for strong, we are using the Ultimaker press tool for the Ultimaker feeders. We use it to press the bearings, the metal bearings, into the Ultimaker feeder. If it's not properly straight, it's going to cause some problems at the back of your feeder. I had to ask one of my good friends from Ultimaker, Daniel Bocking, about this because he told me that they use this in production. And it had to be very reliable and strong because this is a production tool. So in this case, what we have done here, taking a look at my screen now, this model, as you can see, is not entirely flat at the bottom. So this is not automatically dropping to the build plate. Our Z position is 1 because we want to put support underneath because we want to keep this shape underneath it. And it is also laid down horizontally because if we print this standing up, it's not going to be that strong because when we lay the layers down, it is vertical. I will talk more about that later when we go through the orientation. One of the nice things that I would like to mention here is we have more walls here because it keeps the shell thicker. And the particular decision to choose that infill pattern that we have right now. Actually, we will go through it later as well in detail. So, Kostas, can you tell me why we are using this for beautiful?
Yes, well, this is actually a roller blade that was developed, and the point of this is to show it as a prototype to maybe stakeholders or other people so that they can get an idea of how the end product will look like. And it's the beautiful part because we actually don't care about strength or dimensional accuracy in this case. We just care about that it looks nice.
That's correct.
And it plays another functional role that might be worth mentioning here, is that it's for validating for injection molding tooling before going to produce this in a different mode. So in this case, tuning it to really suit 3D printing is not as important as it is to get those surfaces the way that they should look in an injection molding process.
So I'm going to talk about our third hero now. And our third hero is the assembly. The assembly that we have, we call it assembly because it's multiple parts. well, it's one part, but there are two different meshes in it. In my screen right now, if you're looking at it, I have here that our assembly as a whole group. So we have this part, and I'm using control click to individually select the model, because if I just select on it, since it's a group, it will select the whole thing. So I do a control click, and this is the top part, which is printed with Extruder 2, and this is the bottom part, which is printed with Tough PLA. So what does this do? I asked one of our engineers as well, actually two of our engineers, our print farm operator, Kevin Van den Bos, and also Daniel Bocking. They told me that this has to be strong because it helps our operators in production to put the belt inside the slider blocks of our printers. So this thing here, it is, wait, I also have it here printed. Yeah, so it's right here. It is attached to another device that they press down so that the slider blocks would clamp closed.
Okay, so now Terri-Ann has showed us how she has arranged the parts, the hero parts, and it's fairly straightforward because she knew exactly what she wanted to accomplish with them. But we thought it would be worthwhile spending a little bit more time going through the 3D control software tools so that you understand for your parts. We're going to start with importing your part.
Yes. So when we say import your models into Cura, we also mean open your models into Cura. And you can do that with this icon on the left. That is an open folder. It is pretty self-explanatory. It lets you open all the supported file types that Cura can open. And then you can also access this on the file menu, which is on the left. You can also open recent files. Recent file means files that you recently saved or files that you recently opened.
So you can import even more types of files inside Cura by using certain plugins that were developed for this exact reason. So if you open the marketplace and you see that there is a plugin for your specific CAD program, like the SolidWorks integration, once you download this plugin and you have it in Cura, this will allow you to immediately open a SolidWorks file in Cura, which in the background, the plugin actually converts it into a format that Cura already knows, like an STL format. But it actually saves time from your workflow. So instead of exporting your file from SolidWorks into STL and then importing it into Cura, you do it with a simple step.
Instead of having an export for this part at this time, and you get everything that you need from that.
Mm-hmm. When you've actually loaded the models already, so say I've already opened them, there are ways that you can still reorient it after you've loaded it in Cura. So these are the tools on the left that I would like to go through together with you. And I just want to let you know that you can move them around, you can rotate them, you can change the size of the models that you have loaded, and you can also flip them. I believe that we will still go into detail about this a little bit later.
Great. So now let's continue our exploration of the 3D control software aspects, moving across the top now to the section to assign extruder types and materials.
Yes.
So Terri-Ann, you can show how that works.
If you press this, you have to change your configuration, right? When you want to print something by default in Cura, it will always be generic PLA when you start it. But when you add the printer and you connect to it and you open this menu, it will immediately give you the available configuration that is currently on your connected printer. So in this case, Matt's printer has blue PLA and black Tough PLA. And if I click this, it will, well, I already synced it, so it's not going to change anymore. But normally it will be like this. So it'll just be generic PLA. And if I click this, it will sync my Cura into the configuration that is currently on the printer. But you are not limited to this. You could also even modify the materials by going into custom. And you can select from the list of generic ones or Ultimaker materials. And if you want to modify your print core, you can also do that here. And you are not limited to only one extruder. If you have multiple extruder, you can also modify that one specifically. So in this case, I'm in extruder 2, and I also have the option to disable it. So you can disable or enable an extruder, which means that it's not going to be used by Cura. But you can also make your own materials, right, Kostas?
Exactly. So in case you cannot find your material inside Cura already, or you cannot find it in the marketplace of Cura, because you can find a whole lot of materials actually in the marketplace, then you have the option to create your own material. What this means is that if you go to this materials page that Terry is showing, by the way, you can access it by pressing Control K. You can select a material that might be very similar to the one you have. So, for example, in this case, it's the generic PLA, and you can modify all the settings that you want related to this material. This means that now this pink PLA, it will show, of course, as pink, but it will still have all the necessary material-related settings set for you, because it has drawn them from the generic PLA. And of course, you can change other stuff like Terry showed, such as the cost of the filament and the weight of the filament, so that you can calculate how much is your own print actually costs.
Now we get to spend a little more time with the transform tools. So Terri-Ann started to show these before.
Oh yeah, so we want to show them the different tools that we have. I'm going to go back to my strong hero because I really like this hero. I'm going to move it in the middle. As you can see, moving it in the middle, I use the arrows. But I could also use these tools on the side. So I will leave the Z to 1 because I will print support with it. And maybe I also want to modify the scale, so I can make sure that it's uniformly scaled, and then I increase it a little bit. And I can also use rotation. This is actually a nice feature that was contributed by field of view. So now you can see the arrows pretty well. And if I drag it like this, then the object will be rotated. We also have a nice feature for rotation, which is called select face to align to the build plate. It's a really long name. We don't know what to call it. So we just named this feature based on what it does. So what it does is, if it's enabled, so I click on it, and then I select a face of the model. The face that I select, it will lie down on the build plate. So it will face down on the build plate.
And Kostas, do you want to share, you had some interesting bed adhesion strategy suggestions.
Yes, actually, once you have oriented your part on top of your build plate, you need to make sure that the part that is being printed actually sticks on the build plate so that it doesn't move around along with the print head. That's why we use adhesion. And for adhesion, it will create a brim or a skirt around your object. These are actually two different types of adhesion strategies in order to make sure that your part will stick. But in case you want, you can even remove the adhesion completely to make sure there is nothing around it.
Yeah, so that's what I'm actually doing right now. I'm changing the build plate adhesion type. And yeah, now it's none, so you won't see any build plate adhesion around the model. I wouldn't recommend none all the time. Just please use adhesion so that your model will stick to the build plate.
So now we're going to take a look at the support strategy component. Now we're going to talk about most of the slicing parameters in the next section here, but this one is worth having in mind from the very beginning. So, Terri-Ann, do you want to get us started with how you think through support settings?
Yes. The best support strategy is no support. Because support, it adds time, it adds cost, and it also causes scars on the surface of your model. And people don't usually want that. But it cannot be helped because sometimes you will have models that have overhangs. An overhang means parts of the model that that if the nozzle tries to put material on it, it's just going to fall into the build plate. So you need something to support it. That's why we call them support. I actually have here in my screen right now that I want to show you. And there is an interesting YouTube video about this. They tried to, this guy tried to find out what is the best orientation to print a bolt. And of course, at first glance, you would be like, oh, I would like to print it this way because I don't need support. But Kostas, what do you think is the strongest of these three?
Well, I already know the answer.
Oh, you already know the answer? Okay.
But this is actually a perfect example of a trade-off between settings inside Cura. I'm going to spoil it for you, Terry, but the strongest part is actually the one on the right. And as you can see, and that's because of the orientation of the part and the way the infill is generated inside the part, which makes it tougher. And but the trade-off is that you actually need support in order to print this, and you have to use more material in this case.
Something that may be helpful for those thinking about support material is there are strategies for producing support material with the primary build material. So you're actually printing support material that's generated by Angle using the same material that you're printing the part, but the software knows how to make slight adjustments, little air gaps, different temperatures, different speeds of laying down the material that makes it easier to remove that material and leave the primary part that you intended. But you can also create support in a dual extrusion machine and actually have a dedicated support material as that second material. And there you can have something like PVA, which is water soluble, or Aquasys, which is a high temp water soluble that we've mentioned in a previous webinar, as well as breakaway material, which doesn't chemically bond with the part, so you can peel it away with pliers. So Kostas, you were talking when we were discussing this topic in the past about some of the other support strategies in Cura right now. Do you want to share those?
Yes, actually, the most common used support is the normal support, as we call it. If you check, there is a setting called support structure. And the normal support that we see right now is the one that Terry is using. But there is also an alternative that recently came out of the experimental settings of Cura, and it's called a tree support. Tree support is the mental baby of one of our Cura developers, of Ruben, also known as the Ghost Keeper. And its intention is to save as much support material as possible while properly supporting your mesh. And it has the added benefit that it is also much easier to remove than usual support. And it's exactly what you see right now in Terry's screen.
So next, we're going to go to another set of tools further down the left toolbar. So Terri-Ann, you want to talk about per object settings. I know this is an area of expertise of yours, and a lot of our users really want to know more about these.
Right. So what I want to show next is the per object settings. Per object settings are, these are tools in Cura that not a lot of people know about. If you have seen my previous webinar about Cura, I talked about the modifier meshes and per object settings. Now what I want to talk through them again, but really briefly. And the first thing that I want to show you is the support blocker. You know this as the support blocker, this tool that I'm pointing at right now. But this is also known as the don't support overlaps. So previously, I don't have any support blocker in this part, but now I do. And anything that this intersects with, it basically just removes the model on that part. And that's what, yeah, it blocks the support. So that's why it's called support blocker. So don't forget, this is also the same as the don't support overlaps. There is a complete opposite of this, and that is the print as support. So if we change this, this mesh into print as support mesh type, then this box that I currently have selected will just be printed as support. So in this case, now it removes the support completely. And if I turn this as print as support, then it will become a support. While we are waiting for this to slice, I would like to show you the modify settings for overlaps. So I have a different Cura that is open here. And I want to show you a practical application of where you can use this. Remember that the modifier meshes can be applied on any object that you load in Cura. It doesn't have to be this support blocker. So I noticed that with customers, they use the support blocker so that they could add an object into Cura. And yeah, so now that there's a cube here, then they would just change the mesh type of it, and then now it's print as support. But if you look at the lower left in the object list, it will still keep the name eraser. And eraser is what we call the support blocker. So it is a very quick action to do, but just know that you could load other models and then just change the mesh type. Why do you want to change the mesh type of it? Maybe it's because you have a model that has a hole, and you want this hole to be strengthened. So in this case, I would recommend to load a different model, change the mesh type to modify settings for overlaps, and then change the settings that will strengthen this area of that model. So in this case, I would recommend to increase the density and maybe increase the wall line count. These settings that I've shown, we call them per object settings. You can select them here in this menu, and then modify settings for overlaps, and then select settings. So if you have multiple models in this build plate, and you want to print them all at the same time, but they have different settings, you can do that by using the modifier meshes, by using the per object settings. So now all of my models are in different locations. Yeah. So then I can do this, and I can change the settings of these models. So I can make sure that only the model that I select will have this particular setting.
Kostas, you wanted to share about modifying your settings.
Yeah, once you have spent all this time to create the perfect set of settings for this exact print, and you have oriented your models, and well, you have even tested it, and the result is just exactly what you want, you also want to save that, and so that you can even reproduce it later again. And this is where the project files come, and this is where the 3MF format also comes in handy, and why we use it so widely. So the 3MF format, which will be produced once you select to save the project, it will produce and it will keep inside the file not just your models and the way they have been oriented or transformed, but it will also keep everything around them. In this case, for example, the printer that you used, the specific materials, the specific preferences, the settings, the quality profiles that you have selected, and even other stuff like post-processing scripts. Everything will be saved in one simple project file, so that you can make sure that you can reproduce the exact same result every time.
Excellent. Thank you very much, Kostas. So now we move on to the next major stage of our masterclass here, and we talk about the slicing process itself. Okay, now let's talk about the 3D slicer components of Cura. Why don't we start with the Cura recommended settings? One of the first things you'll notice if you've seen Cura in its early days, or any slicer software out in the world, it's a very long stream of possible parameters, etc. But when you look at Cura recommended mode, you only see a handful of parameters on view. Kostas, tell us more about the recommended settings.
In case you noticed, while Terry was scrolling through the settings list before, as you said, there is a whole bunch of different settings that you can change. In fact, there are over 500 different settings that you can modify in order to get your perfect print. This isn't really that easy to do, especially when you are just starting Cura for the first time, right? So in this case, we decided we looked to create an easy settings option for Cura. And we identified all the elements that we felt play the biggest role when you're trying to make the perfect print. And that's why we selected these specific settings. These are the entry stuff that you will most definitely need to change.
Okay, now Terri-Ann, click on custom mode and let's bring out all the big guns.
You know what? I can actually begin with the visibility settings. Did you know that on the upper right, this will give you an easier access to a set of settings? So basic, I clicked on basic. Basic will give you settings that are quite easy to understand, things that we would recommend that is quite easy to change for the user and quite important as well. Layer height, it changes the height of your layer. And the smaller it goes, the more detailed your part is. And if it's much higher, then it seems more coarse. Shell is about the wall thickness. But these are all things that I think Kostas has already given a little bit of background earlier about our categories. And if you want to go further, I would recommend to check out Advanced. Then you have even more settings. You have more information on your material, settings, on your speed, even support. You see there's so much more settings now that is available for me.
Okay. Now, if you spend a lot of time in here and you pick the settings that you want, then you have the opportunity to save those settings as a profile. So, Kostas, you were going to explain, solve for once and for all the mystery that some of our users have with keep versus discard.
Yeah, this is a dialog that pops up once you once you have modified some settings. And for example, if you select to show a different quality. In this case, what this dialog tells you is that, hey, I'm going to change the quality, so the settings that you have changed and you have not saved yet will be overridden. And here the table actually shows on the far left side is the column that has the settings that you actually changed. The middle part, the middle column actually shows you the profile that you are currently in. And the current changes is what you actually changed. So in this case, if you select to keep the changes, of course, since Terri-Ann selected again the same and the engineering profile, if you keep the changes, it will override the changes that you have made in favor of the profile that you select.
So that takes us to our next topic, which is slicing optimization. So we want to take just a second to talk about this. So this phrase refers to the process of tightly tuning the processing parameters to suit a specific part or class of parts. And the reason that this is such a dark art is that slicing for FFF always has, and likely always will be, geometry specific, meaning that it isn't really possible to produce a single magic profile that solves any shape of part you feed it. You always want to be able to have the options to make changes in these various elements. So baseline profiles and material profiles are best guesses. They get you pretty close to where you want to go. And as you learn more about hardware, software, and materials, you can improve on those guesses and dial in a better and better set of decisions to noticeably improve your outcome.
To do a good check, to validate all of the settings that you are changing every iteration, I would recommend, as what I mentioned earlier as well, to check the preview mode. Whenever you are in the preview mode, it gives you a preview. It gives you a preview of your print, of how it's going to be laid out. And with this, this is really useful to customers. Oftentimes, whenever we get some issues, they would do some screenshots of this, or we would do an actual call and we would go, can you go to your preview, so that we could see what is actually there. So I'm often surprised at how people can be so creative and so smart, about how they use our settings.
Right. Okay. I just wanted to validate that indeed this is a very complex domain. We have to stress that, and with the sheer amount of settings that are available, this in the end boils down to experience and creativity, as Terry mentioned. So don't be afraid to play around and try to check the result of each action that you make or each change of setting inside the preview mode.
Yeah, and if you feel that you get overwhelmed by a lot of the settings that we have, know that there are a lot of references, a lot of resources that you could check. We have our knowledge base, we have the Ultimaker Academy, and we also have the Cura settings guide, which which we are proud of. Settings guide over here, and if you use this, you will get a lot of information. It will even contain GIFs, so you could see what a setting does, what is the difference. So check this out if you are lost.
I use the settings guide all the time. It is a fantastic resource. I mean, just
Yes.
understanding how each, what the effect of each change that you might make would be really, really helps. And I have a best practice that I'd like to recommend for those looking to get better and better at slicing. That instead of every time you want to print something, changing a whole array of settings at once, to instead just pick one or two choices that you think will help and run a small print, a technical study, and learn something from your decision. A really easy way to do that is go on and save your project file and title it with the time and date setting of when you were doing this test. Then you can throw that into a print log, and you can know what the effect of that setting was. That way, you can start to build up understanding over time instead of constantly going through and trying to change a whole bunch of things. Because trust me, moments after you hit print, you've lost a lot of the memory of how you selected what part. And so you need things like the project files that contain that information for you.
And
Yeah.
actually, there is a specific plugin that can help you with the naming conventions called um, custom print job naming, if I remember correctly.
I'm looking.
And
Yes, custom print job
yes,
naming.
custom print job naming, exactly, which
Great.
does exactly what Matt says. It creates the naming convention so that you don't even have to think about it. It automatically generates the name of your of the specific print.
Okay, so that's a overview of slicing optimization techniques, and this is something you can spend a long time really developing. And not every part really goes through this process. You don't necessarily spend multiple iterations to get really the perfect slicing. You can lean on the existing material profiles and default profiles and be really close to what you want. But it's good to know how this works. So if you're starting to particularly like do something repeated in production, or find a way that you can always be slicing a type of part more and more easily, it's really handy to do this. So now we go to a very exciting part of this. It is now time for us to slice the hero parts.
Yay.
So yes, so Terri-Ann has been doing a lot of research into ways that other people have sliced these parts, and what her instincts were for how to slice them. And she's going to guide us through, starting with the strong part.
Yes. So for the strong part, there are a few settings that I would recommend that you take a look at if your intention is you want your part to be really strong. One of them is the wall line count. It's already thick enough as it is for the size of the model, so this is okay. The next part that I would like to recommend is the infill pattern. And the infill pattern that is the strongest is the grid. And we said that the infill patterns also differ depending on what you want to achieve. So in this case, grid is the strongest. And I also have another one, and that's this is more of a best practice setting, and that is print the outer wall before the inner walls first. So I am enabling this, and the reason why this is nice to enable is because when your printer actually lays down the outer wall first, it solidifies the outer wall. And when the walls that are printed, they tend to push against each other. So if the outer wall is laid out first, it will maintain the rest of the material that is being laid out will mostly maintain that shape. So I would advise to enable that setting so that you could keep that shape as a best practice. And also, of course, the orientation. Make sure that your orientation for objects like this would be lying down, and just similar for what we saw with the bolt, because the material is laid out horizontally. Yeah.
Yeah. Excellent. So that's the strong part. Now, what about the beauty part? What are some of the ways that you made decisions for how to slice the beauty part?
All right. So I will begin with our, I will show you now our beautiful hero. And in order to show this to you easily, the settings that I've modified, I will just use the feature that Kostas was telling us about earlier. So here, now you can clearly see the settings that I've changed. So support, I enabled it because as you can see, this model cannot be printed without support. There's a lot of overhang here, and Cura highlights the overhang with this red color. And okay, so now I'm going back here. I have generated support. I chose extruder 1, which is generic PVA. So extruder 0, that's Ultimaker Black PLA. And I have decided that I want to prioritize XY over Z for my distance priority. That's because I want to increase my support XY distance. So this setting, it used to be 0.26, and I just want to increase it. That's because I want to put a distance between my support and between my models. Because, as you know, the support can cause some scarring on the surface. And that is the same reason why I also decrease the support horizontal expansion, as you can see here. When I enabled support, I wanted to make sure that I have a support interface. But you also have to be careful about the support interface pattern that you use. In this case, for support interface patterns, I would recommend to use lines or zigzags. And the build plate adhesion type, it shows up like this. We know that this is an issue. It just shows, even if you did not modify it, it still shows up. We also have the avoid printed parts when traveling. So this is also a nice, this is also a good habit to do. I would set this to false if I'm using materials that ooze a lot. So TPU, TPE, PP, I would recommend to set this to false if that's the case. So in this case, since I'm using PLA, you don't really need it right now, but I enabled it I set it to false for the demonstration purpose.
So at this point, I would like to mention that I'm noticing that Terri is using a visual fine profile, which is at 0.1 millimeter layer height. And well, this is actually a very thin layer height, but you can go even to a smaller layer height, like the extra fine. Mm-hmm. But as you notice, the slicing or the printing already will take 5 days. So this is a good example of how there is a good trade-off between time and beauty inside the Cura and its settings, especially when it comes to visual parts like that. So if you want to increase or to make your model even prettier and smoother on the outside, which means smaller and really tiny layer height, then you will have to pay for it in time. This is actually for most materials, except as Matt informed me, it's not the case for TPU, which apparently, even if you reduce the layer height, you don't get much out of it. So it's best to just keep the highest layer height and save on printing time. But that's just for TPU. Anything else, just you have to balance this trade-off. Mm-hmm. And aside from that, I would also like to mention another setting that is very commonly used to beautify a part, and it's the ironing. It actually does not apply in the specific part that we see right now in the screen, because it mostly applies to parts that have a flat top surface. And in this case, what the ironing does is that it brings down the print head, which is already warm, and it starts touching a little bit the top surface of the part where you want to apply the ironing, thus creating a very smooth feel on that specific part.
So now let's look at the third hero part. Let's look at the assembly option.
Yeah. So for the assembly part that we have, there was not a lot of special settings that we have to be careful about. We do need to remember that this is a part that is merged. So we have a setting in Cura that allows you to merge and allows you to group. So for grouping, they're just together, but for merged, they are put together based on the point of origin of that model when you created it in CAD. And in this case, this model that I have, they're currently separated. So I'm going to group them together, and now it's just one model. When you have assembly parts, there are multiple objects in it. I would always recommend to disable the automatically drop models to build plate. Because if they are not yet grouped with each other, one of them will just drop on the build plate. And sometimes customers don't know that, oh, hang on, this is, why does it keep dropping to the build plate? And then we have to tell them, yeah, there is a setting that, you can disable this. I would also like to get your attention to this shadow at the back. So this shadow at the back is what we call the prime tower. The prime tower appears when you are using two models that can string a lot. So the prime tower, it is a structure that Cura automatically does for you so that it can prime the material when it changes the nozzle. So at this point, this is dual extrusion. That's why the prime tower is there. When Cura has to print the black part, and then it's done, and then it has to start printing the white part, it is possible that the nozzle is still extruding a little bit of that material. So in order to make sure that that is not going to string, it will deposit that material first on the prime tower, and then it will prime the next material. So in this case, the white part. So it's going to prime the white part first, and then when it's ready, it's going to start printing on our model. Be mindful of the position of this prime tower. And you can modify the prime tower position in Kostas. Where is this? Yes, there it is. The prime tower
Prime
X and Y.
And Y positions, yes.
Yeah, so I would recommend to keep in mind where this is located.
Okay, well, so let's go to the last subject related to slicing parameters. While we don't have time in the session to print each of these parts to completion, there is an important stage you'll want to follow when you print, reviewing and troubleshooting the resulting part. So Kostas and Terri-Ann, do you have favorite resources for helping you evaluate your printing results? Kostas, you want to start us out?
Absolutely. Actually, at this point, I would again recommend the settings guide plugin. I cannot stress this enough on how many good resources it has inside. And one of them is actually the troubleshooting section, which gives you, it shows some common problems that can occur with your final print and how you can go into detecting them and then maybe fixing them, yeah, as Terry shows right now. Like stringing on the object or yeah, bed adhesion problems, basically lots of different issues that you might encounter on final prints.
Yeah, to be honest, I myself use this. So whenever I'm encountering something or when I see people online who are complaining about stringing or what do I do if there's a lot of pillowing, I just say download the Cura settings guide, check the troubleshooting, and you will find what you're looking for. Like 99% sure.
Perfect. And I have to be a third to celebrate that settings guide. It really is handy and represents a lot of thinking and collecting of information from across the entire community. So very, very helpful there.
these are information that were written by Ultimaker employees themselves after consulting with engineers from R&D. So I would also suggest to take a look at these as a source of support for your troubleshooting.
Okay, so now we have already done the 3D control software portion of figuring out where your model should be and all the parameters to get it ready for slicing. We've done 3D slicing and gone in depth with some of the 500 tools there within slicing that you can use to make your decisions. So now we're at the exciting part, the 3D printing. The print management also includes new packages that Ultimaker has made. We've made it for our hardware, but there are other tools like this out in the world. So we're going to share a little bit of Digital Factory with you, so you can see how Ultimaker is taking this last stage of printing and print management and really giving you a lot of resources and tools. So Terri-Ann, would you like to come visit?
Yes, I am so happy. I am so excited. I can't wait for this part to tell you about the Digital Factory. So I'm very proud of this. This has been really useful, especially now during COVID times. People are not in the same location where their printers are. They want to see what's going on, but it's far away. So we have what we call the Digital Factory. For people who have been using Ultimaker 3s, Ultimaker S5s, and S3, in the previous versions of the firmware, it used to be called Connect, Ultimaker Connect. We have changed it to Digital Factory, and what I can do right now is, actually earlier I've shown you that I'm connected to Matt's printer in Brooklyn. What I'm going to do now is I am going to send this print job to Matt so that he can print the robot in his printer. So you would see on this upper left that I'm connected via cloud, and that's because of this cloud icon. And this option as well to print via cloud is available on my lower right. Now, don't forget that there are still people who would like to print with USB, and we accept that. We acknowledge that, and it is still possible to do that. So you can save the file, and if you save the file, it will let you choose to save it locally as well, in a USB or in your own storage. What is important to know with cloud printing is it is secured. That's why I am logged in right now. So if you have downloaded the latest Cura or the few versions before it, there was an option to log in into your account. With 4.7, at least from 4.7, Cura automatically syncs the printers that are added into your account. So in this case, Matt's printer, he connected it via cloud, he activated the cloud services, and then he shared the printer to me, and that's the reason why I can see his printers in my list. So I'm changing my view now to the Digital Factory, and you can see the rest of the printers that I have in my account. So we have a print farm in Geldermalsen. That's why there's a lot of printers in my account that you see. And this one is Matt's printer. It's just by itself. So this is his printer right now, and I can also see the configuration. It has blue PLA, black tough PLA, and that's what I used as well in Cura. Now I'm gonna print this. I'm so excited. So I pressed the print via cloud, and now it was sent to Matt. So Matt, oh my God, there it is! I hear it.
Yeah, it's getting started. It's exciting.
Yeah, so I would invite...
You're sending an old friend.
Yes, I'm sending an old friend, our old friend, the Ulti Robot. So I would invite all of you viewers to check out this Digital Factory. Try out the remote printing. You can monitor what's going on in your print job as well. If you go to the Digital Factory and you log into your account and you check out your printer, you will see what's going on. You will get this image, and you can also see a webcam view. So right now it's like this because there's nothing there yet. It's preheating and everything. So you have to wait. But yeah, you will see information about your print job wherever you are, anytime you want. So check it out.
And this is just one of the tools that Ultimaker software has developed that sort of extends beyond what Cura has done in the past. There's also Ultimaker Essentials, which takes this sort of experience and actually beefs it up with an enterprise-grade security and additional tools so you can use it within a company and with protected IP. And there is the Ultimaker Academy, which is a e-learning platform for training that already is linked up to these elements, and you can go and get additional training. You can get training for your IT team to know how to actually execute essentials, and we're building more all the time. Chances are, by the time you go to check, there'll be more things to look at.
Yes, I would recommend people to stay tuned because there's a lot of exciting stuff going on. I mean, I can't wait to tell you right now, but I'm not allowed to, so.
Yeah. So for now, we'll have to rely on the fact that there are a lot of resources for you at ultimaker.com to show you the print management tools and essentials, which is is about to wrap up its early access, and you can see some of the new things as they arrive. So with that, we have reached the end of the masterclass sequence. I'd like to thank our experts again, Kostas and Terri-Ann, for joining us today for this Ultimaker masterclass focused on optimizing your Ultimaker Cura workflows.
Thank you very much, Matt. It was a great opportunity to be part of this webinar.
Yeah, thank you so much, Matt. I'm really happy to be here and talk about the things that we're passionate about.
Has this info been useful to you? Then find more great training over at Ultimaker's 3D Printing Academy. At the time of this masterclass, only a fraction of the e-learning training content currently in the pipeline has been launched. So make sure to check back later this fall and at regular intervals in 2021 and beyond to learn more about the training opportunities we now offer. And for any viewers who would like to improve their Ultimaker Cura skills, we have a few suggestions for you. First of all, we will send you a link to this session as a recorded video shortly, so you can continue to draw on the excellent suggestions from our experts. You can also keep up to date with Cura's latest versions by reading the release notes, either at the ultimaker.com blog or within the application itself. The Ultimaker software team are hard at work improving and extending Ultimaker Cura and other aspects of our software ecosystem, so check back frequently. Also, the Ultimaker Marketplace plugin, the settings guide, which got a lot of love here, is an evergreen resource for better understanding each slicing parameter within the custom settings. I use it all the time to make sure I understand how the latest tools that are launched relate to each other. And that, along with the new troubleshooting section, can help you get solutions to your Cura problems quickly so you can move on and do more with your printer. And for those working within larger teams and companies who need enterprise-grade collaboration, I want to reiterate Terri-Ann's suggestion that you can contact our business development team and find ways to get directly involved with Ultimaker. Thank you again to our viewers for attending today's Ultimaker Masterclass. Thank you for your interest and for the amazing projects you're collectively accomplishing every day with your 3D printers.